June 16, 2026, late morning in Central Sulawesi, Indonesia. The ground moves, and for the people of Palu, the memory of 2018 moves with it. This is what a magnitude 6.7 earthquake looks like when it strikes a region that is not finished healing. At 11:27 local time, BMKG recorded a shallow earthquake centered 42 kilometers southeast of Palu, near the Sausu area of Parigi Moutong. Depth 16 kilometers, shallow enough that little energy was lost before reaching the surface. Shaking intensity reached level 6 to 7 on the MMI scale in Sigi and Parigi Moutong, strong enough to be felt across multiple regencies and strong enough to send people into the streets. These are unfiltered moments from the ground. Hospitals in Palu moved patients outdoors as a precaution, some still connected to IV drips. In Sigi, residents described the shaking as the strongest they had felt since 2018. We're not adding music to heighten this. The footage speaks for itself.
Gempa, Marvin! Putri keluar, gempa!
Damage was concentrated in Sigi, Parigi Moutong, Palu City, and Poso. The Sigi Regent's Office sustained damage. In Palu, the Tadulaku University Auditorium, the Santika and Best Western hotels, and several commercial buildings were affected. Engineers temporarily closed the Palu 3 bridge after inspectors found cracks, a reminder of how a single earthquake can isolate a region that depends on a small number of road links. Regency. At least 38 people were injured. Across Central Sulawesi, 841 houses were damaged, most of them in Sigi, ranging from minor cracking to severe structural failure. 2 offices, 15 places of worship, and a village-connecting bridge were also affected. Local authorities mobilized emergency response within hours. By the following morning, BMKG's Palu geophysics station had recorded 466 aftershocks, the strongest measuring magnitude 5.2. Most went unfelt. Authorities report the frequency is already trending downward. The residents near damaged buildings have been urged to remain cautious. BMKG attributes this earthquake to the Sausu Fault, operating through a normal faulting mechanism, the crust pulling apart rather than thrusting upward. This sits within one of the most structurally complex zones in Sulawesi, where the Sausu, Palolo, Male, Parigi, Tokararu, and Saluki fault segments intersect near the Lore-Lindu fracture zone. It's worth noting the timing. Just 8 days earlier, on June 8th, a magnitude 7.7 earthquake struck offshore Mindanao in the Philippines, generated by thrust faulting along the Cotabato Trench, where the Philippine sea plate subducts beneath the Sunda microplate system. These are 2 different fault systems with 2 different mechanisms: extension in Sulawesi, compression in Mindanao. BMKG stated this earthquake originated from local fault activity, with no confirmed triggering link to the Mindanao event, but both lie within the same broader tectonic neighborhood, a zone where the Philippine sea plate, Sunda plate, and several microplates converge. Near simultaneous activity in such a setting doesn't prove causation. It does, however, make the region a genuinely active natural laboratory for studying how stress moves through fractured crust. Central Sulawesi's governor ordered an immediate emergency response, directing medical teams and local officials to assess damage and meet basic needs. For a region still rebuilding from 2018, this event is a renewed test of preparedness, and so far the response has moved quickly. Central Sulawesi sits on some of the most tectonically active ground on Earth. Understanding why these earthquakes happen and how the region responds is what we do here. Subscribe to Epic Earth Events. Understand the Earth.
Bono!